Let's look at compounds and their formulas. So compound is any substance that's composed of two or more elements, and these elements are combined in a definite proportion, which is by mass. So we will look at what this definite proportion means, basically meaning that we can randomly combine these elements. In order to have a specific compound, the elements needs to be combined with each other in a specific ratio. So what you see here is water molecules, and water molecules are composed of oxygen and hydrogen molecules. In order to make water, each water molecule is composed of one oxygen and two hydrogens. And in order to make them, for example, for two, you're going to need one oxygen molecule and two hydrogen molecules. So compounds are composed of two or more elements. You should also know that when we make compounds, there is a possibility we can actually decompose the compounds into the elements, into what they're made of. So those are called decomposition reactions. Now, one thing to keep in mind, which is very important, is that elements in the compounds are always combined in a whole ratio. We can have fractions. For example, in the decomposition of water molecules, we have two water molecules here, and in order to make two water molecules, you need one oxygen molecule and two hydrogen molecules. You can have 1.5 oxygen, or you can have, I don't know, 3/2 hydrogen. These elements, they have to combine in a whole ratio to make different compounds. Now, there are different ways of classifying, categorizing elements. One of the classifications is that we classify compounds into two groups, molecular and ionic compounds. So for each one of these groups, we want to see how they're made of, what they're made of, how we write their formula, and also how we name them. So molecular compounds are those that are composed of two nonmetals, or a nonmetal and a metalloid. And ionic compounds are those that are composed of a metal and a nonmetal. Now, the difference between molecular and ionic compound is basically in terms of the attraction forces between the elements. So molecular compounds are composed of nonmetals or nonmetals and metalloids, and the forces that holds these elements together are called covalent forces or covalent bonds. But for ionic compounds, which are composed of a metal and nonmetal, we're basically dealing with charged species. Charged species are called ions. So the attractive forces in between the positively charged species and negatively charged species are ionic forces, which are very strong forces. Now, when two, let's say, element or two ions combine, they form molecules. And molecules are the smallest unchanged individual unit of a compound. Now, in a sample of compounds, we can have many or infinite number of molecules. We will actually learn the number of molecules we can have in a specific samples. But keep in mind that we cannot break molecules any further. If you break a molecule, you change the identity of that compound. So as soon as, for example, water molecule is broken into hydrogen and oxygen, you don't have water anymore. You have hydrogen gas and oxygen gas. So once elements are combined to form molecules, those molecules, if they are broken, their identity changes. So molecules are basically the fundamental units of compounds. Now, we talked about ionic compounds very, very briefly, and I told you that ionic compounds, they're composed of charged species, and I also mentioned that charged species are called ions. Now, if the charge of your ion is positive, that becomes a cation. And if the charge is negative, that becomes an anion. So let's look at formula of compounds and see what information we can get from the formula of compounds. So for now, I just show you the formula, but we will learn how to write these formulas and we will learn how to name them. So the formula that you see here is the formula of sulfuric acid. So what information can I get from this formula, H2SO4? Based on the formula, you can tell what your compound is composed of. So basically, looking at this formula, I can tell that sulfuric acid is composed of hydrogen, sulfur, and oxygen. Does everybody see that? Now, based on this formula, I can also tell how many of each element need to combine in order to make sulfuric acid. So the subscripts show you the number of elements, the number of atoms in each molecule. What does it mean? So if I look at the formula for sulfuric acid, I know that in the formula of sulfuric acid, each sulfuric acid is composed of 2 hydrogen atoms, 1 sulfur, and 4 oxygen. Now, the rule is that if you have more than one element, you have to use subscripts to show how many you have. But if you have only one, we don't write the number 1. So here in the molecule of sulfuric acid, you only have 1 sulfur atom, but we don't write the subscript of 1 for sulfur. So anything more than 1, you gotta write it up. The other thing also to mention or to pay attention to here is that these subscripts have to be whole numbers. They can't be fractions. And the subscripts also have to be the smallest whole number. Now let's look at different ways that the formula can be written. This is the formula of calcium nitrate. Now, by looking at the formula, I can tell that calcium nitrate is composed of calcium, nitrogen, and oxygen. How many calcium atoms? Very good, 1 calcium. How many nitrogen? 2 of them. So the subscript for nitrogen is 1, and it's in parentheses, and the subscript for parentheses is 2. So 2 times 1, it means that you have 2 nitrogens. How many oxygens? Very good, and 6 oxygens. So when you have parentheses, keep in mind that the subscript for the parentheses applies to every single element that's inside the parentheses. Now, one other thing to mention here is that these formulas of compound, they tell you what type of elements and how many of each are in your compound, but they don't actually tell you how these elements are connected to each other. In order to see how they're connected, we have to look at their structures, their Lewis structure, which we will talk about it later. Now let's do a couple of examples. K3PO4 is the formula of potassium phosphate. And we want to know how many of each element is present in potassium phosphate. How many potassium? Very good. 3 potassium. How many phosphorus? 1 phosphorus. And how many oxygens? 4 oxygens. Let's look at another example. This is the formula of magnesium hydroxide. You will learn how to name these compounds. So magnesium hydroxide tells me this formula, that this molecule is composed of magnesium, oxygen, and hydrogen. How many magnesium? 1. How many oxygen? Very good. How many hydrogens? 2. So what I want to show you here is how different elements are combined to form. And remember that the proportion of how these elements combine with each other is extremely important. For example, here you see 2 different compounds, H2O, which is water, and H2O2 is hydrogen peroxide. So these 2 compounds, both of them are composed of same elements. They're both composed of hydrogen and oxygen. The only difference between these 2 is the proportion, the percentage of the oxygen and hydrogen that are combined. So in H2O water molecule, you have 11.2% hydrogen, 88.8% oxygen. But in H2O2, 5.9% is hydrogen, 94.1% is oxygen. So what this means is that only if oxygen and hydrogen combine in 88.8 to 11.2 ratio, you will have water molecules. Any other proportion, what you have is not going to be water. It's not going to have the properties of water. Now, if you combine oxygen and hydrogen in a 94.1% to 5.9%, you will form hydrogen peroxide. Hydrogen peroxide and water, they have totally different physical and chemical properties. So just the type of element is not important. Also, the proportion in which they combine is also important. That's called the law of definite composition, meaning that each compound has a definite composition of different elements. So the other thing that I also want to mention that these percentages are mass percentages, and you will learn later on how to find these mass percentages. Now, having said that, also keep in mind that we can combine elements in different ratios to make different compounds. This is called the law of multiple proportions, meaning that atoms of two or more elements, they can combine in different ratios, and if they combine in different ratios, you can make different compounds, and those compounds, they have different chemical and physical properties. And these are some examples. For example, copper and chlorine, they can combine in different mass percentages or percent compositions. So we can either have copper 1 chloride or copper 2 chloride. Another good example is combination of carbon and hydrogen in different percent compositions. So these are all methane, octane, these are all different types of gases, but depending on the percent composition of carbon and hydrogen, you get a different type of a gas. Now, since we talked about law, I just want to remind you again the difference between law and a theory. So remember that law, there is no exception in a law, but when we talked about theory, there are always exceptions for theory. So the law of multiple proportions or the law of definite proportions, those are laws, and there is no exception for them.